Hello, everyone. Let's go ahead and give them about a minute before they join, and then we get started. Thank you all for coming. Okay, my name again is George Ndede. I'm one of the facilitators of this program, and I would like to welcome you and also thank you for taking your time to come and join us. This class today, we are going to go ahead and cover the last two topics. And the last two topics will be dwelling on some of the things we've been doing, but now in a deeper detail. And one of those will be talking about the loops, like iteration, like repeating something over and over, but now in a programming environment. And then another thing we are going to talk about is list, but now list into detail. We did list before we did the dictionary and the tuples. And the person who is going to be heading this class today is none other than Ruth Amolo. Ruth Amolo was once one of my students, very outstanding, and she is here with us. And Ruth, please go ahead and take it over. Thank you. Can you hear me, Ruth? Unmute. Can you hear me, Ruth?
Yes, I can hear you.
Unmute. Oh, go ahead.
I've already unmuted.
Oh, go ahead, please.
Yeah, so welcome everyone. It's nice to meet you for the first time. I've not been logging in because of one or two reasons. I'm going to take you through loops, and I'm going to share my screen with you. Can you allow me to share?
You're ready to go. Just go ahead and share. You're ready to go. Just go ahead.
Windows. Yeah, so Python has two types of loops, three, but basically we are going to dwell on two, that is while loop and for loop. Just like Migot has said, loops are used basically to execute a sequence of statements multiple times until maybe a given condition is met. So if you have a background of loops, even just writing pseudocodes, it is possible for you to understand even how a simple code works. So I don't know if you're going to work with it. You already have your Python loaded, because some of these exercises we can actually go through them, or we'll be going through and then you'll be trying them as we move along. I'm using Jupyter to run my Python codes. And when you're using loops in Python, that is for control and while, they also have what is called loop control statements. And these loop control statements, we have the break statement, continue statement, and pass statement. Break statement is important because you want to, sometimes you want to break a statement, you want to stop executing the loop. Yeah, so you want to bring the loop to a stop. Maybe you have reached a certain level, and then you wanted it to get out of the loop. So you break out of the loop. Then we have continue. Continue statement is used when you want to skip that iteration when the condition is met. It allows that loop to continue with the next iteration. So we'll be looking at those examples. So the difference between continue and break is that the program will not terminate, but for the break you can terminate, you can get out of the loop. But with continue, it will just continue working, but at that point maybe it will just skip. Yeah, so we'll be looking at those examples. So we'll get into while loop. So while, just as the name suggests, you need to execute a set of statements as long as a condition is true. So you find that you have to use a relational operator to test the condition. So even if you have used pseudocodes, you must have used relational operators at a given time. So it has a syntax. Syntax is just how it works, the format. So you say while condition, then you have the block of statements, statement or block of statements. So on my screen, we have the first example there. For you to execute the while loop, you must be testing something. So if you look at my screen, we have I is equals to 1. So we are using that I. It is I that is being tested. So you say while I is less or equal to 5, then you want to continue printing the value of I. Then you say I is equals to I plus 1. So in Python, you can write I is equals to I plus 1, or you can say I plus equals to 1 is the same as writing I equals to, in pseudocode, I know you do that much, I is equals to I plus 1. So that is just the same thing. Then you look out for indentation. Python is very particular about indentation. If you just interfere with this indentation, maybe I just move it like that, you find that already it's giving problems. Yeah. So it's very important to look at the indentation. So in the next example, when you say you can use while loop, and then at the same time use it to input data at the same time. So you initialize variables. Let's say you wanted to count as you enter the figures you want to count, and also you want to add. So you say while count is less or equal to 6, meaning we want to enter at least 6 values. So we'll have our test text. So this is input, enter your number. So let's execute. I need to run the code. Anyway, let me load it again. Yeah, so sorry for that. You initialize the count to 0, and then also sum equals to 0. Then while count is less or equal to 6, then you assign a variable called test text to input the number. So you can see what I'm trying to input. You put it in quotes. I think you've been running that. Then this is a function called input. These are inbuilt functions. Then you test the number. This is for converting the number, the text to number, because when you enter something in Python, it is treated as text. So if you want it to convert to a number, you say int test. You say int, then bracket the variable. So what is inside here is the variable. That int is also a function, but you're using it to convert what you have just inputted. Then we say print, the number you entered is, then it will pick the number that you have converted, the variable that you have converted. If you pick this test number, it will not work. So make sure that you pick the number which you have converted, the variable which you have converted, which is called test number. So the sum is equal to sum plus test. This is helping you to accumulate the number which you are actually feeding into the computer. So you say sum is equal to sum plus test. So before the variable, we have sum is equal to 0. You initialize the variable sum. You also initialize the variable count. So when you say count is equal to count plus 1, it will be accumulating the numbers as the incidences of entering the numbers, while sum will be adding up the numbers that you'll be entering. Then this will print the numbers in the console that is on your screen and gives you the print statement. The print sum so far is sum, will give you the total number of the numbers that you've been entering. Then you have while loop using break statement. If you look at the upper example, the first and second examples, you just introduce the break statement. I think earlier on you were taught how to use if statement. So immediately after the I, then you can test if I is equals to 3, then you write break. And please take note of the indentation. Indentation is very important. Then if I is equals to 3, so you introduce the testing of the, so when you generate this number and it reaches 3, then it will break, it will terminate. So the another loop control, you can control the loop using continue statement. Yeah, that one I repeated is still break. So you can also use continue. I think I had it down here. So this is also else. You can also print a message once the condition is false. So look at how else has been introduced there. You type else and then you put a full colon. Then this message will be printed as soon as the else is executed. Are we together?
Yes, we are.
Yes, we are. Yeah, I hope you're with me.
Yes, we are. Thank you.
Yeah, so
yes, we are. Thank you.
The other example is example 6, where you can create a list of even numbers. Let's say even numbers between 1 to 10. So you initialize, let's say we are starting at number 1. So this is odd nums is just a variable, and you want to put these variables in a list. So you say odd number is equals to an empty list. So if you have heard about list of you've tried it using it, you can also have an empty list. So initialize it just on top of while loop. Then you say while number, which is the number here, number 1. if num, if the remain, this is you want to, if the remain, you are dividing this number by 2. So if the remainder is not equal to 0, is not equal to 0, then it's an odd number. Then this append is a function that is used to add these numbers to the list, the empty list. So this empty list will be populated with these numbers. Then if the number is more or equal to 10, then it breaks, it terminates. Otherwise, it will continue doing what is called counting. So this is used for counting. Number is equals to number plus 1. Then it prints the odd numbers. So that is basically what this statement is doing. Then the other example, we have number is equals to 1. Then while number is less than, we have also another control statement, which we are calling pass. While number is equals to, or less or equal to 10, then if number is equals to 6, then you pass, else you print num, and num is equals to 1. So we had 3 of them up here: the break statement, the continue statement, and the pass statement. So in the pass statement, you can use it when you want to do nothing, when the condition is met. So it does not skip or stop the execution, it just passes to the next iteration. So if there's another iteration, it will just continue. So for break, you can use it to bring the control out of the loop. Sometimes you want just to bring the control out of the loop, or continue, you want to skip that current iteration, but allow the loop to continue for the next iteration. So I don't know if the students will be allowed to do some exercise, just one. If they look at the screen, they try, or we'll move on. Can they try the first example? Are we together? Are we together?
Yes, we are.
Yes, we are. Yeah, I don't know if they're able to try from their computers, or we'll just move on. Yeah, because I want to show them the for loop. Yes, so for the for loop, there's a slight difference with the while loop. The for loop can be used to iterate, that is, repeat a sequence of statements. So if you have used the lists, the tuples and dictionaries, the sets and the strings, you can use the for loop to print out the content or to go through the this type of data. So with the for loop, you can execute this statement. Remember, the statements usually you can put them inside the for loop. So for example, we have, this is an example of a list. So this list is assigned the value of fruits. So you can say fruits equal to, this is a tuple, sorry, it's not a list. We have the smooth bracket, that is the list. The tuple, sorry. For the list, it is the square bracket. So we assign the tuple a variable called fruit, and inside we type various types of fruits. So you say for X. So remember, X is a variable which you are assigning to the tuple name fruits. So you are not supposed to put X on this other side, the right side of for, right? Between in. So you say X in fruits. So fruit is the tuple name. So this X, you give it another variable called X. So then you say print, I love, then that is just a statement which you are printing. So, excuse me, you have to put it in brackets, in quotes, sorry. Then you separate them using a comma. So the variable X is what you're printing. If you put fruits here in a print statement, it will not print directly. So it will give you an error. So we use a variable called X. So you say for X in fruits, then say print statement, I love, then that I love is just text, string. So you put it in quotes, then you put a comma, then you put X, comma X. So X is the variable. So it will print all this. Then you can use it also to print tuple based on which is having numbers. So you can see it's just the same pattern. Tuple numbers equals to. So for n in tuple numbers, so print n. So it will just print number 1 up to 5. Then if you go to the next one, example 2b, you want to iterate through a list. So remember the list has the square brackets. So you can see the pattern is the same. So we have for fruit in, then you print the fruit. So the next one we have example 3, use loops to see the content. You can also have letters, yeah. For L in tuple letters, so then you print L. So it's very easy, very simple to master because you don't have to, it's just a pattern that you master. So you can see for variable in, then you assign the tuple equals to, then the tuple is on your right-hand side. That is the data you want to work with. Then on your left-hand side is the name of the data type. So that is the tuple letters. So you say for L, which is the variable in tuple letters, then you print and look at the indentation. So for also uses break, just like while, the break statement. So the break statement also can be used to stop the loop before you through all the items. So on my screen, I have the fruits: mango, apple, dragon fruit, grapes, and guava. So the same way for X in fruits. So if you want to use break, you have to introduce the if statement. So look at this. If A is equal to, so you put those double equal sign, dragon fruit, then you break. If it reaches that part of dragon fruit, So you'll see that it will only display the first two fruits. So it will terminate the loop at that time, at that point. So grapes and guava will not be listed. So if X equals to dragon fruit, then it terminates when it reaches dragon fruit, then it prints the list. Then continue statement is working the same, except it will leave out the dragon fruit. It will list everything except the dragon fruit. So if X is equal to dragon fruit, continue. So what continue does at this point, it will omit or skip the dragon fruit, but prints the last fruits, which is grapes and guava. So if you look at the pattern, it's just the same. So coding in as a beginner, coding is not so difficult. You can actually master this if you have basic understanding of pseudocode. So don't shy away from starting to learn coding. You'll be great even if you just know how to write pseudocodes, because pseudocodes, the patterns are almost the same. You can say for I is equals to 1, 2. So the pattern is just the same. Using for statement, you can also use range. So the range will help you also to return a sequence of numbers, starting from maybe a 0, which is the default, and it will be incrementing it by 1, and it ends at a specified number. For example, in this case, you start at 0 for X in a range. So if you put there a number like 5, it will print numbers between 0. So there are 5 numbers. So 0, 1, 2, 3, 4, and 5. So if you count them, there are 5 numbers. So if you count them, there are 5 numbers. Yeah. Yeah, so this one is now executing. Let's say I've changed that to 10. So if you execute, when I execute, I just press enter key, then it just generates the numbers between 0 to 9. That count makes it 10 digits. So basically this one is representing the digits. So if you put there like 7, then it will give you 0 to 6. So if you count them, they give you 7 digits. Very simple for X in range. So you just use it to generate numbers. So a for loop can also be used just to generate numbers. Then example 6, you can use for loop using range, and you combine it with break. So that is the beauty of this. You can combine both the break and the range. So for example here, it doesn't have to be X. You can replace num with any other variable. So if you put X there, it's still just a variable. For num in range 1 to 15, if num equals to 7, you break. So this was supposed to be generating 15 numbers, but this one is terminating after generating 7 numbers. So if you put break there, it will terminate once it has generated 7 numbers. And if you look at this, it is starting at 1, 2. Yeah, so that's the difference between this one and the first one, which is generating from number 0. But this one is using range, but it has been forced to start. It has been forced to start at number 1, and it will generate starting from number 1. So that is the difference between for X in range 7 and for num in range 1, 15, sorry. So that is the difference. Yeah, so if I change number to terminate at 10, it breaks at 10, so it will generate from 1 going down. When it reaches 10, it breaks, so 10 is not printed. If I put there 11, yeah, so 10 will be printed. So if it reaches 11, it breaks, so 11 is not printed. This one is combining break and then continues. Then example 7, you can use for loop. Example 7, you can use for loop to using range and combine it with continue. Oh, that one done it earlier, so it's not necessary. We have red, green, and black. Then you have the numbers 1, 2, 3. So you can actually say for X in color and for Y in number. Then you print X and Y. So it will combine the color and the number, the color and the number. So you can see there color is X, which is the first one, then the number, which is the second one. So it is starting with the red, then it is going to the second one, which is green, then it is going to the third one, which is black. So even if you change this one to another color, you'll see the output will reflect automatically. So it is just as sweet and simple as that. So it is not as scary as you may think. So just look at the indentation and you'll be able to get it exactly the way it is. Then example 10, you write a nested loop program to print multiplication table. So programming is supposed to make your work interesting and easy. I know it may look difficult at first, but when you look at it keenly, you'll find that it is just the same for statement that we are looking at. So let's say we say for I in range, that is 1 to 11. So if you look at the other example which we are working on, here we state clearly you are starting from which number to which number. So remember when we used range somewhere up here, range 1 to 11. So which means it will give us up to somewhere here, range 1 to 15. So if number is equal to 11, we break. So range up to 15, the same range we are applying it here when we want to generate the multiplication table using Python. So this is nested because we have two for loops. So when we have more than one, then we call it nested. So for in another for. Then we have this and we have this. So this one to iterate from 1 to 10, the same thing, we are iterating range 1 to 11. So it will print I multiply by j. So the first one is I, the second one is j. So this one is just helping us to terminate, reach the end of the line. Then we print. So you'll get this kind of multiplication table. Then you can also use Python for loops to generate a pyramid pattern of numbers. So let's say this one is a stair of 1, 2, 3. So if you look at it, we assign rows to contain the 5. Then for I in range 1, you add row is row plus 1. So you add row is row plus 1. So for j in range 1, then I plus 1. Then you print j, then you terminate the end of the line, each line. Then you print that space. So you can get a pyramid of patterns. Then example 12, you can also invert that pattern with the same digit. So here we are just producing 10, 10, 10, 10, 10, 10. So we use their negative for reversing that so that it can be able to appear like inverted. Then the last statement, which is print /r, that one is not for, R is not for the numbers, but it's for spacing the characters, yeah. Then we have the last example there for fourth statement. We have inverted pyramid patterns. So if you look at that, we can replace what you're printing here is the star, and the star is inverted. So the same thing is up here. We have 10 number of rows. The number is equals to rows. Then you reverse the loop. For I in range, rows 0, -1. So it's just the same thing, but instead of printing number 10, which is number here, we are printing the star. So that is what I've just put in quotes, then single quotes, then a comma, and then that one for the termination. So that is for the for loop. So basically, if you look at it, it is not as difficult as it may sound, but if you try the exercises, I think it is very simple. Are we together?
Yes, we are. Yes, we are.
Any question from there up to this point?
Anybody has any question? Anybody has any question? Just proceed. Just proceed.
Okay. Yeah, so I want to move to the next part of this, which is the functions. Yeah, functions also sound complicated, but it is not complicated. You can see my screen, functions.
Yes, yes.
Functions?
Yes, yes, yes.
Yeah.
Yes.
Yeah, so a function is just a group of related programming statements. So most programming statements are using functions to perform specific tasks. So we can have that block of statement, and then you want it to perform something, so you use the functions. So usually programmers are encouraged to use functions because they save space, and also this chunk of the program can also be broken into modules or chunks or small statements that can be able to be used to perform something. So it makes it easier for programmers to organize their work and manage also a large program. For beginners, you'll be working maybe in teams, and maybe you're given some tasks to do. So you'll be able to keep a track of what you are doing currently. And then you can also avoid making repetitions, and also you can reuse those codes. So once you have a group of tasks put in functions, you can just call that function and use it elsewhere. So in programming, we say you make it reusable. So in Python, we have different types of functions. One, we have inbuilt functions. These are functions that you find inside Python. They're already there, just like when you are using Excel, you have sum, you have product, all those inbuilt functions. And then even in Excel, you can also have what is called your user-defined formulas. In Excel now we call them formulas. So in Python, we talk about user-defined functions. These are functions that you yourself, you come up with. Maybe you want to have a group of statements that you want to help you do achieve a certain task. So you will give it a name of your choice. That is called user-defined function. Then we have another type of function, which is called anonymous function or lambda functions. Yeah, so an example of inbuilt function is the print statement that you are using. I think some of you have tested Python. You've been typing that print statement a lot, even input statement. That is also called a function. So it will help you mostly to see what you are inputting and what you are outputting. So for the print, you'll be able to see the output when you execute the codes. You'll be able to see them from output. Then input, when you capture data using your keyboard, you are able to use that input function. So there are quite a number because that is another lesson. We'll not even delve into that. Then user-defined function is mostly what I'm going to show you here. These are the functions that you are going to come up with in order to help you achieve a particular task. So we call them customize. So if you want, your end goal maybe is to calculate maybe area of a circle or something like that, you can employ user-defined function. So the inbuilt function, you can just see a list of them. We have the type, object, input. If you want to read something from your console, that is the keyboard or something like that, then it is converted by the computer. Those are the functions: int, round, absolute, format. Those are built-in functions. So a function in Python, which we want to talk about here, the user-defined, it consists of various components. One of them is the keyword, which is called def. It marks the beginning of the function header. So the function must start with that word def, def. Not deaf for person who can't hear, but def. So def, def. So the function name must be unique so that it can identify that function. Then the name is it follows the same rules of writing identifiers in Python. And I think maybe when you're starting, the names that you are using to identify variables in Python, you should be able to know the rules. So the same rules also apply when you are when you are writing the name of the function. Then a function also has what is called parameters. Yeah. arguments through which we pass values to. Yeah. Then we also have a colon to mark the end of the function header. So when you write the name of the function, at the end of it, the first line, you must put a full colon there. If you leave that full colon, it will give you an error message. Yeah. Then we have what is called optional documentation string to describe what the function does. So you put that in quotes, it's optional. Then one or more valid Python statements, which you put in between in that function so that it can be executed. Then some functions you can put a return statement, though it is optional. So this is the simple syntax which you can have in a typical function. The first three letters, D, E, F. Then we have the function name of the function. Then inside we have the parameters. We'll just look at an example. Then the document string, which is you can leave out. Then we have the statements that you want to execute. So a simple one is just a greeting program, which you can use. You can create a program that greets people. Yeah. So def, I told you that is a keyword which must be present. Then if you look at the function on the screen, it has a different color. Yeah. The def has a different color, it's green. Then the name of the function, which is greet. Then we have the parameter there, name. So you print hello. That plus is just combining the word hello and combining with the word good morning. So that is just used to combine whatever you want to display on the screen. So if you have already written your function, how do you use it? How to use it, we say you call it. So to call a function, you make it appear somewhere so that it can be used. So remember, we use the word reusable. Reusable, you can take it somewhere else. You can call it somewhere. That we call calling a function. So on my screen, we have the keyword def. That is the name of the function. Then we have that in bracket, the parameters. So the function there, that is just explaining. This function greets is to a person passed in as a parameter. Then it prints hello, name plus good morning. So as I can say greet Ruth. Ruth is the name, the variable there, which will be passed here, given the name Ruth. So if you look at my screen from the output, that is what it will produce. Hello, Ruth, good morning. So Ruth is just the variable which the data which you are passing, and the variable which you are using to pass that, which is coming from the function, is called name. So if you look at the print statement, the name will be picked from the defined state, the function, the function greet. But how do you call the function? You write the name in bracket, then you provide it with the data. Functions are very interesting. If you look at this on my screen, you can use it to perform calculations, not just producing text as the first example. Let's say you want to add two numbers. So up there, you put the keyword def, then the name of the function there, add, you can see it has a different color. Then in bracket, those are the variables which you want to use to add the numbers. Then we have result is the variable which you're using to perform that addition. So you want add A and B. So A plus B, then you want to return the result. So you can see the return is also a key, it's a special word which is used there. So you are not supposed to use it for putting variables, because it's recognized by Python as a keyword. So those keywords, you can see they're given that color green. So return result. So if you say print add, so it is calling this function the same way we were just calling greet. Greet, then you provide the data. So you can say print is also a function, but built-in function. But this add is user-defined function, user-defined function. Yeah, so I've just changed the figure there to 6. So 6 plus 2, we get the value 8. So suppose I change this one to C. What happens to my code? It produces an error. It is producing an error because it was not declared in the function where you are declaring the variables which you want to use. So Python will consider that as an error. So if I do this, what happens? Again, it is still giving me an error because when I'm calling the function, it requires that the same variables I declared up there, they're the same variables that I'm supposed to be providing their data here. So if I want to this thing to add, I need to provide the 3 variables, and I need to provide data for the 3 variables. So here it is not given me an error message, though it has just added A to C. It has just added A to C because that's what I instructed it to do. In computer, we have something called garbage in and garbage out. Yeah, so this is possibly a logical error. So you might be wondering, why am I getting 4? Yeah, and I'm expecting to add 2, 6, and 2. So I need to put this so that I don't get that logical error. So if I add B, you can see my output is now different. So that is called debugging process. When you get an error message, you don't panic. You just check in the message. Let me just get back there, then we see what the problem was when we removed C. How you can be able to tell where the error is. So you can see the on my screen, add, that is, add is the function name, takes 2 positional arguments. Yeah, so these ones are called arguments, but 3 were given, only 3 were given. Yeah, so 3 were given. So arguments take 2 positional. So if I add another argument, that is C, yeah, then it will not give me an error. But still I get an error because I did not include the 3rd variable here, which is B. So if I include it, it is corrected. Again, if I don't supply the 3rd one, what kind of error will it give me? It is missing a positional argument C. Actually, it is even telling you which one is missing. So it knows that the first one is given 2, the second one is given B. So it means that C, which is the last one, is missing. So we put another number for it. So you separate those ones with a comma. Are we together?
Yes, we are. Yes, we are.
Yeah, so basically when I was executing the code, you realize that it was giving you some names and words, parameters, and arguments. So a parameter is just the variable listed inside the parentheses in the function definition. So for example, we had a name there. Then here we had the ABC. So the name is the parameter, and also the letters A, B, ABC. Those are called parameters. Then an argument also is the value that is sent to the function when you call it. So here we called add the function, and the values we gave it, 2, 6, and 7, they are called arguments. So when we put them here, we send these values so that we can assign them to the parameters which we have stated up there under the add function. Then sometimes you can just give the parameter a default value. Default value means you automatically give it a value at the beginning of the where you are declaring the variables. That is the parameters. So we've agreed to call them now for parameters. So A, B, and C, we can call them parameters. So at the point here in the bracket, within the bracket, you can decide that you want to give them the values directly. So when you give the values directly, we call that default, by default. So by default, it is A is 3, by default, B is 2. So when you say result is equals to A plus B and returns result, it will add those two numbers automatically. So assuming you change this one to 10, then our output will automatically be 13. So you say sum equals to add, you assign it the variable sum is assigned to a function called add. Then you print sum, so it will print the variable sum. So this sum now is assigned to this. So this is also another way of using the function. So you can give the default values a value direct at the beginning where you are declaring the parameter names, you give it a variable. So functions have very many applications. So you find that in real life situation, you'll be doing things like payroll, calculating payroll. And here is a situation where you are doing calculating wages of an employee. So we see there are two, you can see there are two functions. One is just specifying the calculations which you need to do. We have an example of pay with overtime. So when a person's work hours for the week and regular hour wages, you calculate the total pay for the week. You take into account overtime. The hours worked are over 40, are paid 1.5 times the normal rate. So this is a place where you can apply the function. So one, you put this for just showing the formulas, how you are going to effect the calculation. And you can even see the if statement is applied there. So if the total hours is less or equal to 40, then the total wages is hourly wage multiplied by total hours. Else, overtime is total hours minus 40. Because if you're doing overtime, it means you have done more hours. So when your total wages is hourly wage multiplied by 40 plus, this is somebody who has worked overtime. So 1.5 times the hourly wage multiplied by the overtime hours. Then it returns the total wages. So the first part is where the person has not worked for overtime. Else is the second part where the person has worked overtime. So how is this called? So if you look at the second part, we have two functions here, the first one and the second one, and we are calling the the main function, that is the function that is being called. That's how it's being called. This one is being called at this point where the calculation for the total is done. So the user will be expected to input. So for example, if I work for 12 hours, yeah, then enter the dollars paid per hour, I'm paid at 20. Yeah, so it executes and you are able to, you don't even have to look at this. This is done on one function, another function. So if it was just one statement, it would be a very long statement. And you can see the outputs here. We only have like 3 lines. But whatever this has done, if we were having so many input statements and lines to do, but here we're just calling this line and then calling the calc weekly wages. We are calling the first function. So are we together to that point?
Yes.
So I hope you are not lost. Some of you are not lost. Yeah, so a function may also not have parameters specified. So you can just have the brackets enclosed and it does in the function. So let's say this one is going to print the Pascal triangle and we have its size. So for I in range, 0 to size. So for J in range, 0, I is equals to I plus 1. Then print the decimal number. I know this one looks complicated, but this was just to show you that you can use a function as well to produce the Pascal triangle and combine it with the for statement. So you can combine the for statement, you can combine it with the functions, and you produce the Pascal triangle. Remember, we were using the for statement to produce a pattern. And this pattern, I believe Pascal triangle is just a pattern, just like the patterns that we were producing in for statement. Are we together?
Yes, we are.
Yes, we are.
Yeah, so I believe I didn't, okay, that is all I had for the function part. And we'll be going to the list comprehension. So list comprehension is also used in Python, and it gives you a shorter syntax when you want to create a new list. Remember, you have lists, you have tuples, you have dictionaries. So you want just to create a list of things. So if you look at the for statements that we've been doing, the while statements, we've been talking about these lists and the tuples a lot, because we find that most of our data are in terms of lists. So the list comprehension will provide a more compact and elegant way in which you can create lists than for loops, and also allow you to create lists from existing lists. So you can create a list from an existing list. So let's say you have a list here of fruits. So with an if statement, you have to use the first example here, which we are going to look at. you have a list of fruits. So this list of fruits, you want to produce a new list. And this new list which you want to produce out of it, you want to produce a list if they have names having letter A. Yeah. So we are expecting guavas, apples, bananas, and mango to be in that list. So if we are using the for statements and if statements, so you say for X in fruits. So if A in X meaning this list, if any of this is having a character called like A, then we are going to produce a new list. Appending is just to add into, yeah, so we are appending this to this list here. Yeah, this is a new list. New list equals to, this bracket means we want to create a new list. So this is a variable called new list, but it is assigned to an empty list. So we are basically assigning the word new list to an empty list. Yeah, so if X in fruits, so if A, we want to pump these fruits which are having the character A in a variable X. So new list dot append X. So if you print this new list, we'll be getting guava, apple, banana, and mango. So, but we can use list comprehension to make this one very simple. If you look at the code, it looks more of complicated and we have so many lines, but we can make it a bit easier. So what does this list comprehension have? So the list comprehension, we have the variable on your left-hand side. Then on the right-hand side, we have the expression for the items in iterable that you want to iterate. Then the condition, then if the condition is true. So my list X for X in fruits, if X is not equal to apple, so not equal to returns true for all elements rather than apple. So let us do it practically here. Example 2, you will achieve the same result like the upper one. So the second example is where we are implementing the list comprehension. So we have the list of fruits, guava, apple, banana, cherry, kiwi, and mango. So our new list, we have X for X in fruits. So if X A in X, then you print the new list. So this is what we'll get. So this is just one line of statement. If you compare with this, we have for X in fruits, if X in A, new list, we have how many lines there? Almost 1, 2, 3, 4, 5 lines of code. You compare with this, which we have eliminated when we are implementing list comprehension. So this is going to replace like 5 lines of code. So it makes the code to be compact and it reduces the number of lines that we need to write. So it's just that the pattern that you have to master. So let's say we introduce which other fruit has an A in it.
Pineapple.
Not orange, but orange will not have an A. Oh, pineapple. Oh, even orange. Eh? Yeah, so if you execute it, you can see the way orange has been added automatically. So if you compare the two codes, that one does not in code 3, it does not implement the list comprehension. The 13 implements list comprehension and it is very short. So here you have to introduce the if A in X, that is a different line. For X in fruits, that's a different line. new list, and an empty list, that's a different line. So just by using one single line statement, then you're able to do that. So example 3 here, you can also use it with the numbers and combine it with range. So x equals to I, for I in range 10. So that is, you have 10 figures or numbers, yeah? So if you count from 0 to 9, that is, it comprises 10 numbers. So that is also list comprehension, very, very, very direct. So example 4, where a dictionary is applied, so you can use list comprehension. So my dictionary, assuming that you can see the dictionary, we have the curly brackets. And that X, we are raising it to power 2. So 1 raised to power 2, that's like 1 times 1. That's, you get 1.
Yes.
So this is these are the numbers which we are raising. 1, 2. Yes. You see, X times, that is the multiplication, the 2 stars. So if you look at the 2 stars and then the 2, we are raising X to power. That's a power times, so 20, that's 5 times 5. You get 25. 3 power 2, you get 9. 4 power 2, you get 16. Yeah. So that's basically what this is doing. Then list comprehension, you can also include conditional statements. So in this case, use if statement in list comprehension. So for example, our numbers here, the list of numbers, X for X in range, and our range is 10. So if X, we have the remainder 0, you divide by 2, you get remainder 0. That means they're even numbers. So we want to produce even numbers between 0 to 10. So you can see on my screen, we have even numbers. So if I change this to 20, you can see the list has been adjusted. So those are basically even numbers. So what this statement means, the number, when you divide by 2, you get a 0. So those are all even numbers. So another option, another example we have is example 6. We still use nested if with list comprehension. So you can have, there are 2 conditions there. You check if y is divisible by 2 or not. And you also check if y is divisible by 5 or not. So you can see from my screen, all these numbers, they are divisible by either 5 or 2. So 10 is divisible by 2 and 5. 20 is divisible by 2 and 5. 30 divisible by 2 and 5. 40 divisible by 2 and 5. Up to the last one, which is 90. So for y in range, so whatever is in bracket here, this is the last figure. So if you adjust it to 50, you'll get a different report. So that one goes up to 40. So the last example there for list comprehension, you can also transpose the list and you produce a matrix. So you realize that from these exercises, the for loops are very key and also the list comprehension, very key. The while loops are very key. So you must understand the for loop in order to wade through programming, because you realize that the data types, most of the data types that you'll be dealing with, you'll be implementing the for loop most of the time. Because you find that in real life examples, let's say if you go to the ID sections, even the driving license, they'll be searching for your IDs or even driving license numbers. So you find that most data is either arranged in a form of lists, or they are tuples, or they are in dictionaries. So it's important to know the format of how to use these for statements and for loops, and also how to use the list comprehensions, and also how to implement the functions. So I think maybe you can ask questions, or we can contribute, or if there's some part which you want me to repeat, I can repeat. I started with the while loop. Or I can invite someone from the floor to contribute. Thank you so much.
Thank you very much, Ruth. And, thank you very much, Ruth. I wonder if there's anybody any question. I wonder if there's anybody any question. Any contribution? Any contribution? Ruth, is this for all? This is all you needed to cover today? Ruth, is this for all? This is all you needed to cover today?
Yeah, yes.
Okay, all right. Thank you very much for that coverage, and I hope everybody. Thank you very much for that coverage, and I hope everybody you understood, and please you understood, and please how to practice this fully. How to practice comprehend it fully. Comprehend it. Okay. So Ruth and Esther covered yesterday. Covered today. Ruth and Esther covered yesterday. Covered today. Tell you, programming is not very hard as people may think. Programming is not very hard as people may think. All you have to do is just be able to practice, and all you have to do is just be able to practice and practice regularly. Okay.
Right. Yeah, all the codes are available. Right. Can share them through HTML.
Okay.
So that they can copy and paste and try them out.
Yes, that would be great. Yes, that would be great. Okay. Anybody else want to contribute anything new? Anybody else want to contribute anything new? Anything you didn't understand? You need more elaboration on? Anything you didn't understand? You need more elaboration on? Okay. So this brings it to the end of our session.
They're all muted.
So this brings it to the end of our session. Yeah, they're all muted. But I know they'll have questions. They're all muted. If you do have any questions, if you do have any questions, yeah, just feel free to contribute that. Yeah, just feel free to contribute that, or ask questions in the WhatsApp group. Or ask questions in the WhatsApp group. Okay, Ruth will tell you. She also started just like you. Ruth will tell you. She also started just like you. It's not hard. It's not hard. Okay, this meeting has
Trevor,
been
you don't
recorded.
have questions?
Okay, this meeting has been recorded.
Okay.
Trevor has any question? Trevor has any question? Okay.
Yes.
All right, guys. Thank you very much for this. And Ruth, thank you so much.
All right, guys. Thank you very much for this. And Ruth, thank you so much
for the coverage. We'll share the recording, and you all have a good weekend. Thank you.
Share the recording, and you all have a good weekend. Thank you.
Okay, bye.
Okay, bye.
How easy.